afternoon, Howard Wiig, Think Tech Hawaii Code Green. My esteemed guest today is Nick Dizon, president of NIDON Energy and a host of other companies, but today we're going to be focusing on some really exciting environmental technologies that he has. We've all been reading in the paper about Hawaiian Electric is stalling the PV process, and the PV people are very, very upset about it, and the PUC, the Public Utilities Commission, is in the middle of the fray. And it's a very, very contentious and very important issue that involves tens and tens of millions of dollars for our state. Enter smart grid, which Nick will describe, and at the heart of that, smart electronics and smart batteries. One of the many things that Nick does is represent NIDON Energy, which produces batteries which should solve a lot of our smart grid problems. And I already knew about Nick's connection with that, and then I get the MIT Journal, and this particular article features NIDON Energy and the battery technology as one potential problem for Honolulu and a host of other mainland cities developing smart grids where we can incorporate wind energy, sun energy, and any other type of supply with your conventional energy supplies and get a smooth, harmonious, clean, green electrical future for us all. But Nick, before we go into the essence or the technical applications of these batteries, and you do represent another company, why don't you and I were earlier talking about a business model, specifically an energy business model for Hawaii, where we're discussing the fact that we lead the world in resort and hotel and hospitality services. Our local companies get some huge, huge jobs in China, Malaysia, Singapore, Japan, because we are the hospitality industry experts, and you see a future for us as being equivalent to that in the renewable green energy world. Why don't we start off with your describing that?
Well, we're so isolated on our electrical grids. We're held up as an example across the nation and the world as how renewable energy can be integrated into the grid. Our per capita PV penetration is higher than anybody else's. The utility is having to struggle with well over 120 up to 250% of peak penetration of renewable energy. If Hawaii can show that Hawaii knows how to deal with that, that's going to set an example or set the template for the rest of the world. Now, what I've been doing, and you've known I've been doing this, since 1999, is building commercial and residential models and proving that they work. Once those work, we're already, and for what we're doing, they're working now, we're actually training people how to do these things so that in the future, when Japan, Tonga, Samoa, any islands in the Pacific, isolated grids are looking for how they can integrate renewable energy and eventually supplant their diesel genset sources of power, they're going to look to Hawaii, because we will have the skilled technicians, engineers, and construction people that can be exported around the world to go do that. And that's what I'm hoping will be a long-term result of this. Now, the business model requires that, it all requires a functioning business model. So what we need to do is show that you can do it affordably, profitably, that customers are going to want it, and that these products and services have that kind of value. The traditional PV model was pretty simple. You had a bunch of guys go to a house, they looked at the electrical bill, they determined how many panels were needed to supplant that, and that's what's been done for the past several years widely. What we're doing now is we're analyzing the load. We're not looking at the electrical bill. We're analyzing the load, then we're designing a solution to the load with PV and battery. And the designs that we're doing are not, a net energy metering agreement with the utility is not required. because what we're doing is we're taking portions of the customer's power off grid. So if you're in a part of the grid that's highly penetrated, we put this in, you don't need an NEM, but you do need a permit from Department of Permitting and Planning. That business model is what we've been proving. So traditionally, a PV guy didn't have to do all those extra steps. Definitely there's an additional cost because of the amount of engineering and research work, and then of course the battery. But the cost savings, the ROI over time, we believe works out, but it requires that we do an individual analysis of each customer's load to show where they are, how far out the ROI is. And also it gives the customer the flexibility because they're building a infrastructure that's long lasting, that's also scalable and modular, that can result in a completely off-grid solution. And so it's something the customer can decide to do over time as they can afford it. And as of course, over the past few years, we've seen the electric utility rates go up by over 50%. That even with a barrel of oil being as low as it is, the cost of living in paradise doesn't slow down.
Yeah, yeah. So you're saying that a typical customer could maybe start small, and then as he built his income over the years, just add and add and add, and would he end up, excuse me, with what's called a net zero energy home or something beyond that? It sounds like you're talking something beyond.
You could end up with that, but the issue is, what we're doing is giving you the fundamental foundation to take it that far. Really, it's up to you. And as you do that, not only do you reduce your electric bill, you also make yourself immune to power outages. One of the most important things people found out in Puna when the hurricane hit was that they couldn't keep their food cold. And refrigeration is our #1 need.
Absolutely.
Otherwise, you got to constantly go out and get more food. As soon as you make food, it's going to spoil because you don't have refrigeration. So yes, you'll end up with backup power. It acts as a UPS. If we've taken the refrigerator off grid, obviously that's never going to be an issue where the utility has a problem or there's a storm or a car hits a telephone pole and knocks the power out.
So that's your grand business model, and as you said, another thing we were discussing was the way that you learn and you grow your businesses. You try something and then you monitor the holy heck out of it, and either it works or it doesn't work, or it works 90%, and you go back to the drawing boards with your staff and say, why is it only 90%? How can we boost it to 100%?
That's exactly correct. We are not going to sell what doesn't work, and we're not going to sell what we don't believe we have a full understanding of. Back in 1999, when I first went into looking at renewable energy and actually installed a PV battery system, what I found out was the trouble area for renewable energy is how you interconnect to the load, whether that load is connected to the grid or not. That's something that needs to be understood, and what we've been doing since 1999 till now is learning that. And one of the most important things that I need to do, and I've been doing, is starting to teach electrical engineers, electrical contractors, C13s, and my own guys how to do this. Now it's vast. The amount of data, the amount of knowledge you need is wide. You need to know electrical code. You need to know how to draw it up in a one line. You need to know how to do a data analysis. When you go to a home or a business, you need to look at devices, understand what those devices are, be it a refrigerator or a compressor or some kind of three-phase motor or an induction motor, lighting, whatever these things are. So I have to train people to understand what different loads are, how to read the nameplates and understand what kind of power that is. Is it 120? Is it 240? Is it single phase? Is it three phase? And also to ask the customer, how do they use these loads? What's the pattern of usage? Because if you take anybody off grid, they're going to expect that power is going to be there when they need it. We can't necessarily be exactly like the utility, but we need to know ahead of time what they have, and we're going to over-engineer and over-design a little bit so that the customer gets that, we meet that expectation that when they turn on the microwave, the lights won't blink. When the microwave is on and the compressor to the refrigerator kicks on, the lights don't blink. And if you're on your computer when all that happens, the lights don't blink and your computer doesn't shut off. These are things that traditional PV sales organizations and installers have not been doing in the past 7, 8, 9 years. That's something that we're doing, and our staff is being trained up to do that. So it's a different business model. It's more complicated. There's more moving parts. But the results is a lot more people knowing how to do a lot more stuff. And over the years, they start working together better, and we're able to move more products and services out, which I think will ultimately result in Hawaii being an example that can be exported elsewhere.
And how about the implications for, say, Hawaiian Electric? It sounds like you'd be better able to integrate yourself to the greater grid, the entire island grid. Because right now, if you look at the load profile, with all the PV that we have, you go up till about 10 o'clock, and then the PV starts kicking in, and 2 in the afternoon, a huge slice of your electrical supply is PV powered, and then it goes down till around 5 and then disappears. And that's one of the main reasons why Hawaiian Electric is putting the brakes on this. Could you do a better job of integrating with the grand utility?
Well, that's absolutely necessary. I have actually been meeting with the utility, with a lot of their engineer types for the past several years. And their problems are real. And for whatever reason, a lot of the modernization and upgrades that a lot of people have expected the utility to do haven't been done. And it's not necessarily all the utility's fault. Nobody expected the growth of PV to be what it was. It was just hugely explosive. And one of the key mistakes out there when they originally did this was the NEM rate on Oahu for the utility here was set for full retail. If you go to Kauai, it's not a full retail. You do an NEM agreement with KIUC there, it's a wholesale rate, which protects KIUC. As of right now, there's very little likelihood of HEI or HECO in particular turning into a co-op. It's in all of our interests that Hawaiian Electric Company be solvent and sustainable for the foreseeable future. Now, as a renewable energy guy, our ultimate backup power is always going to be the utility. But at the same time, we need the utility. Why? Because where does Costco get power for their reefers, for all that food we buy? Where do the tourists get all their air conditioning and the elevator power and all those hotels around the state? It comes from the utility. That's not going to come from a PV system. They don't have the physical space, and it's just not practical. So coming up with a business model, both on the renewable energy side and on the utility side, is what needs to occur. Now, from our side, we've been presenting what that business model would be. And it's a business model where in a part of the grid that's fully saturated, as you were describing, any PV system there, we would design it not to export to the grid between 9 and 3 in the afternoon. So 9 in the morning to 3 in the afternoon, there would be no export. We would have the load use all the power, and we'd be charging batteries. Then when the sun goes away for PV purposes, say by around 4 or 5 o'clock, we have all this battery power that can be discharged at either the utilities control into the grid at peak or under customer control. In either case, that grid penetration from renewable energy is gone. So now this power becomes available either under the utilities control, under demand response, or under customer control.
Precisely. And on that cheery note, let's take a brief break. And you referred to NEM, net energy metering. Maybe our audience isn't fully familiar with that, so I'd like to start off with that definition.
Sure.
Aloha, I'm Kili'i Akina, president of the Grassroot Institute and host on Ehana Kako, a weekly program on the Think Tech Hawaii broadcast network. Ehana Kako means let's work together. Think of the sad alternative, let's not work together. Here in Hawaii, with all of our diversity and the richness of the people, it's important for us to come together around issues on the basis of what's right and what's good and what's going to serve the common good. And that's what we try to do at Ehana Kako. Every week we interview movers and shakers, people in government, business, and other sectors of society to talk about how to create together a better government, economy, a better world here in Hawaii that can bless the rest of the world. I thank you for your attention to Think Tech Hawaii, and we look forward to seeing you every Monday, 2 to 3 p.m. on the Think Tech Hawaii broadcast network. We're Ehana Kako, and we wish you well. Aloha.
Inspired by an ancient culture, classical Chinese dance, vigorous physicality, timeless stories, 5,000 years of Chinese music and dance. Shen Yun presents authentic Chinese culture. Coming to Blaisdell Concert Hall, May 8th and 9th. Tickets at shenyun.com or call 808-792-3919.
Good afternoon again. Howard Wiig, Code Green, Think Tech Hawaii. My guest today is Nick Dizon, president of NIDON Energy and a host of other companies. But we are focusing today on Nick's contribution to clean energy in Hawaii and specifically integrating with the larger electrical grid to bring more and more renewable energy in a smooth, even fashion. And Nick, we left off last segment by talking about NEM, net energy metering. Not everybody understands that. Can you explain that for a minute?
Well, simply put, in order to recapture value of your renewable energy system, your PV system, the way that the state and the utility came up with it is the net energy metering agreement. You need to submit a application to the utility with the details of what it is you're looking to install. And should you be approved, you'll get a net energy metering agreement, which means your excess power can be sold to the grid, and that counts as a credit to your electric bill. That's been working far better than most people thought. As a result, the utility had to slow down the amount of NEMs, net energy metering agreements, that were being awarded. In fact, they pretty much came to a halt for a long period of time. After, like say, towards the end of 2013, it really slowed down. So the utility announced a few months ago that there was a backlog of about 4,500 applications. And they promised to clear those 4,500 applications by the end of 2016 when the federal tax credit sunsets, which doesn't bode well for anybody trying to get a brand new NEM now. Now, if you're in an area where there's very low penetration, under 75%, maybe you might get one, but understand you're in the queue behind thousands of permits that a limited amount of utility staff are working on. And, you know, to be fair to the utility, that's not a lot of incentive for them to pump those out. They promised to do it, and I'm sure they will, but each one means less revenue to the utility. As a result, when the PUC made a requirement to the utility last year to give a plan that was submitted in August, when you read that plan in the first, couple hundred pages, they have some charts that showed spiraling revenues over the past 4 years. That revenue drop from just raw electric sales is largely due to PV. You can say LED lights and more energy efficient lighting and solar hot water was contributing to it, but the rate of decline and how the decline was sustained was alarming. Therefore, this NextEra deal where they're looking to buy HECO and eliminate that $1.4 billion in debt that HECO is carrying, that's pretty powerful. On paper, somebody like that coming in, if they're willing to help integrate more renewable energy, as their commercials are saying they will, that could be a good thing. But they're going to need to demonstrate that they understand how to tie in more renewable energy on these highly penetrated grids. Now, I think it's incumbent on the guy that's selling you renewable energy to know how to do that, but he can only go so far. He's not responsible for the utility accepting it. So as I was describing to you, the prime net energy metering hours as set by the federal government in terms of what's the best solar hours here is about 5 hours, which is between 9 in the morning to 3 in the afternoon. We, the designer install guys, can make it so that there is no export during that period of time.
Because at that time, the energy is being stored in batteries.
Correct.
So that the utility or the customer can use it at the proper time.
And what we're doing is we're making room on those batteries. These batteries need to work. Even if they're not these modern advanced batteries from ZBB or Aqueon, even lead acid batteries, lithium ion batteries need to be exercised a certain amount. And so in this model that we're outlining, the batteries would discharge into the peak a predetermined amount, or they would intercept the customer's load for a predetermined amount of time based on the data we've collected, how it performs. So that when the sun rises the next day and the PV panels all go live, there's overhead in these batteries to absorb all that energy while running what the normal daytime load is. So what I've just outlined to you is a lot of complexity. You need to know daytime load. You need to know what the load looks like 24 hours around the clock and how it shifts around. And then design your renewable energy and storage system and your power electronics to accommodate that, while at the same time being able to be safely interconnected to the grid to the utilities advantage. As what we're looking for is a win-win. We need a mutual advantage, one for the utility as well as for the ratepayer.
And then from my standpoint as a state of Hawaii energy office guy, we're looking at HCEI, Hawaii Clean Energy Initiative, 70% renewables or efficiency by the year 2030. So far, we're actually exceeding that. And everything you're talking about takes us closer and closer and closer to that goal.
That's exactly true. And while we're heading towards that goal, what wasn't really clearly outlined in the Hawaii Clean Energy Initiative, and nobody could have known at that time, is how the utility would flex to be profitable in that environment.
Yeah, as they're shifting from a producer to a distributor. Yeah.
Right.
Yeah.
That model was, of course, nobody understood that model needed to be in place, or they assumed that HEI or the utilities would understand that ahead of time. The utility is full of really smart guys, and they're earnest, hardworking guys. Where the rubber meets the road, engineers and technicians, electricians, those are all good guys, but they're not the strategists who have to figure out how to make this new evolving business model work, to go from central generation and transmission to distributed and management. Those are nice words that's out there across the nation in the industry, but the practical business model of how to do that, nobody's really dedicated themselves, as far as I know, here locally in the utility to do that. Instead, they're looking for a white knight to come in and figure that out.
Yeah, and you can read about that every day in the papers, the back and forth, the back and forth. I know NextEra wanted to have the deal closed by the end of this year, and you heard it from me first. It ain't going to be closed. 28 interveners, I believe. Yeah.
At least, right?
Yeah. So I know we have some slides coming up.
Okay.
And what do you want to see first?
I think we were showing the wind turbine.
Oh, yeah, here's the wind turbine.
As I mentioned earlier, I actually put in my first PV system with batteries in 1999. One of the other things I wanted to figure out was whether small wind was a good idea. The number one problem in the state of Hawaii is square footage, real estate. A lot of people don't have the real estate, the square footage, to put sufficient PV on their home or their business, or they're in a valley or they're shaded. So a really great way to bring renewable energy is a vertical axis wind turbine. Now that wind turbine pictured there, you've known about it for years, Howard. That was installed, gosh, maybe 6 years in that building.
Maybe,
It's 2015 now, right? So about 6 years ago, we went and put that in, and that thing requires a conditional use permit. So you got to work with the zoning guys. You have to get the conditional use permit before you can apply for a building permit. That's expense requiring engineers that makes that concept not really economically viable for most people. However, that wind turbine has been up for 6 years. I can understand why the powers that be wanted a conditional use permit and a setback requirement because, admitting that I'm an older guy, back in the 50s and 60s and early 70s, the skyline was full of TV antennas. You could have a really small one, or you could have these really big ones, and whenever a wind came, they kept blowing all over the place. It was a horror. And nobody wants our beautiful islands to be cluttered with all these noisy, messy, falling apart wind turbines. Well, we stuck that one up 6 years ago to test out whether it would be safe, whether it would fall apart, and whether it would work. Well, it's safe, it works, and it hasn't fallen apart. Anybody wants to see it, you go down by Best Buy and Costco and Alacava, and if you go in the Best Buy parking lot on the mountainside and look towards the mountains on the warehouse, you'll see this wind turbine. And that's a 4 kW wind turbine from Urban Green Energy, another company that I represent. And whenever you watch a Philadelphia Eagles home football game, they have like 14 of these, like 6 or 7 in each end zone. The nice thing about that is it can make power 24 hours a day. And on a lot of our buildings, there's wind or air pressure, even if the wind is low, because all these buildings act as air dams that all this wind spills around and could spin these things 24 hours a day. Its footprint is small, but if it was making half its rated output, 2 kW an hour, that's 48 kW of power every day.
And as you and I were discussing, this is hooked up to your battery system so that if the wind is blowing steadily at 3 in the morning and the grid doesn't need it, it all goes into the battery.
Well, the issue is intermittency, and intermittency is a huge problem for utility. You can't have thousands of PV systems on all these homes. Every time the clouds come over, and clouds come over every few minutes or so, the power fluctuation to the grid has to be stiffened up by the utility all the way from Kahe. And that's a problem. Putting in battery systems means that we can take all that intermittency either off grid, or if it's on grid, have our inverters interact with the grid automatically in such a way that there's no evidence of intermittency. It's just like a neutral connection. You're
I like that
consistently
phase,
drawing power. We don't want to jerk the grid around. That's bad for us. It's bad for the grid. It's dangerous. So intermittency is solved by putting in the correct type of inverters and these are intelligent inverters with batteries to stabilize the interconnection.
And again, to get back to the wind, we know that the sun sets around 5 or 6, but with wind, it's blowing, as you said, throughout the night, so that you can continue to store at 3 o'clock in the morning, even if you don't need it to feed into the main grid.
Correct. The ability to hybridize wind and PV. Now, if it's a hot, sunny summer day and the trades are gone, or it's variable winds, Kona weather, and the turbine's not turning, but you've got PV, see, what that also does is it changes the programming dynamic of the power that's available to go back to the grid during off-peak. During peak, when the sun's not shining. Peak, the horseshoe peak occurs in the morning and the afternoon where we don't have PV to help us, or help the utility actually. By hybridizing a wind and sun with battery, we can address that to the advantage of the utility, while also having it be a financial advantage to the ratepayer.
Precisely.
But part of the thing about this is even as we take more power off-grid through PV and batteries and wind, it's not like the utility isn't getting more sales. With every new building goes up, we have to put air conditioning, we have to put lighting. But air conditioning is a really big deal, especially if you live EVA.
Yep.
And for every person that's here, we need refrigeration. And that refrigeration needs not going to get less, it's going to go more. And then to maintain and operate all of these facilities and people, we need more equipment that's going to draw more power. But we need to find a balance there in our business models where we're making it cost effective for people to provide these products and services while ensuring that the utility is making a fair profit and is sustainable.
That's what we will be talking about after the next break, and we need to, it'll be our last segment, so we need to get some photos in there too.
All right.
Yeah. Yep.
Hi, I'm Jay Fidel. That's Ted Ralston. You know, Ted is the host of Where the Road Leads. It shows every Friday from 4 to 5 p.m. It's about technology. It's about how people collaborate and solve problems with modern technology. It's where the road leads. We all know that. We should all be listening. Join us there, 4 to 5 p.m. every Friday. Now, what about that do you agree with?
All of it.
I knew he'd say that. Aloha. Say aloha.
Aloha.
Good.
Hi, I'm your host on Think Tech Asia, Bill Sharp. I look forward to you joining us each Monday between 4 and 5 o'clock when we film right here in our studio in downtown Honolulu. The show, Think Tech Asia, focuses on contemporary events in Asia. And by Asia, we mean anything from Hawaii, south to Australia and New Zealand, west to Pakistan, and as far north as the Russian Far East. Clearly, this is one of the most economically dynamic centers of the world, and we bring you up to date on what's going on in a whole host of countries in this very vital region. We look forward to seeing you. Aloha.
Good afternoon again. Howard Wiig, Code Green. My guest today is Nick Dizon, sometimes better known as Battery Nick. We've all heard of battery bills. This is Battery Nick because he is bringing in some of the most exciting battery technology that has ever hit this state. And we're talking about integrating that battery technology with wind, with solar, and above all, with the utility. Nick, you have a couple of other photos to show us here.
Right.
Yeah.
There's about the same time that we did the wind turbine 5-6 years ago, we also brought in zinc bromine flow batteries. Now, flow batteries are not lead acid, and it's a very different kind of technology from what you would think of as a traditional battery. It works like a battery in terms of it provides DC power, but the way it stores power is by plating and unplating zinc. And this zinc bromine is fairly environmentally safe, much safer than lead acid. We brought this in about 5-6 years ago as an alternative to the diesel generator for backup power to an elevator. Now, a diesel generator is noisy. It makes smelly exhaust, lots of vibration. You're normally required, or you're required to do like a monthly testing on it. And then you're supposed to test the fuel, and it requires maintenance, refueling. And the fuel can go bad, and it can jam the filters, and then when you need it, it stalls and it doesn't turn on. So there's only cost of ownership. Total cost of ownership for that just goes up and up. And then in a few years, you're going to need to replace it. And there's a lot of EPA rules that make diesel gensets even more expensive and complicated to deal with. Well, we came up with an idea, and this was a Hawaii-developed idea. This content, this intellectual property was developed here, was to use zinc bromine batteries with a ZBB inverter to be in place of a diesel genset as backup power, emergency power for an elevator. And cool whiz-bang additional thing, we would hook it up to photovoltaics, PV, so that it would always be able to recharge itself from the grid. Now, these batteries are very dense in energy.
Are we looking at them here?
Yeah, that's what a zinc bromine flow battery looks like on the inside. And this battery one cabinet holds 50 kW hour of power. And we have 3 of these there. That's 150 kW hour of power, which effectively takes this elevator off grid. It also means there is a lot of extra power there that's available for use by the utility through the demand response program. So the utility can call upon this power as they need it. This model is extremely attractive because of the environmental advantages, the maintenance advantages, and there's a return on investment versus total cost of ownership. Putting this type of system in on a condominium, an office building, or a hotel means that you've established a foundation that's modular and scalable. Okay, you've just proven that you've taken care of the elevators. Now you can take care of water pumping. You can take care of emergency lighting. Maybe in a condo, common area power can now be run off of this system. And if you put enough PV on it, you could effectively take your common area electrical loads completely off grid while having sufficient, while having power that's available to your utility when the utility needs it.
Now, you mentioned one of my favorite phrases, demand response. And I know that Hawaiian Electric is aggressively pursuing this program. I think they have several hundred demand response customers out there. And I've even attempted to build it into Hawaii's energy code. New commercial buildings shall have demand response capability. You want to talk a little bit about demand response and the implications for the utility being able to shave those peaks and smooth that load?
When you talk to the utility, and I've actually been at these demand response meetings, and you ask them about battery technology being the source of power during for demand response, they will tell you that's the sweet spot for them. See, really, how most of it is supplied is through diesel gensets. Well, the EPA has been really clamping down on gensets the past 5 years. I think about 2 years ago, the rules went from 4-tier interim to full 4-tier, which means that the generators that you buy have to have a certain, you're minimizing the amount of particulate that you're kicking out into the air. Well, those scrubbers and extra technology amplifies the cost of the diesel genset. The other thing is a lot of the buildings around here, or a lot of the condos and hotels were built without diesel genset provisioning. So if you buy generators, diesel generators, you're going to find it's expensive, and you're on the hook for maintaining and fueling the thing. Batteries actually are, from HECO's own point of view, the better source of power for demand response. Demand response is an excellent concept because what you're doing is building a virtual spinning reserve like the cloud is for the internet. Demand response could end up being a cloud of storage available to the utility. And that's to the benefit of the utility and to us.
And can you explain how the utility interacts with demand response customers? They have to enter into an agreement here.
Right. They have to have a minimum of 50 kW of power available for like an hour or something. And should you, there's a fairly detailed application form you've got to fill out to submit to be qualified for the demand response program. And theoretically, you could be signed up for it, but if your part of the grid never has a need for it, they may hardly ever use your power. Now, if you're in an industrial area, like in the airport area, you'll find that there are several companies there that have actually bought large diesel gensets, really big ones, specifically because they were subsidized by the demand response program, because in those particular areas, the utility had a need. And it's really a grid substation by substation determined situation. So if you are in a situation where you think you want to participate in demand response, you should talk to the utility to find out if that part of the grid, there's a recurring need for that.
And from one of our more ardent audience members comes the question, how does this interact with electric vehicles? Demand response.
Well, a lot of people were hoping that electric vehicles could become part of that spinning reserve. Now, understanding.
And here we have it on our screen.
All right,
Yeah,
that's
yeah.
actually a, from a ZBB slide where they show a microgrid charging up electric cars. The thing about electric cars is, okay, first of all, they're all lithium-ion battery packs. And the level of the state of discharge from one car to another can vary widely. And also, what time do you plug that car in? So it becomes not a reliable source of stored energy. If you've been driving it all day long and you come home, you don't have much excess to discharge into the grid. And if your home hasn't been set up with batteries and renewable energy that's designed to interact with that electric car, you could find yourself again in a charge deficit situation.
Yeah.
So what most people have found is that, okay, they save power, they save on their gas bill with an electric car or a hybrid, well, specifically electric car, but then the cost of charging up the car can easily add another $100 to their utility bill. And currently, the time of use, time shifting value for charging their car is about 3 to 3.5 cents.
That's not much.
Yeah, under certain circumstances, you can get it up to 6 to 7 cents if you have a PV system. But if you're on a saturated part of the grid, you can't get the PV system. So you're kind of in a tough area. This is why we're addressing doing systems that don't require that interconnect to the grid. But electric cars are something you gotta really study.
Okay. And is this an electric car system we're looking at, or what is? No, I think these are the Aqueon batteries.
These are the Aqueon batteries.
Yeah.
These are the cat's meow. I personally believe that for most stationary lead acid applications are going to go the way of the VHS tape versus a cassette versus CD versus DVD. These batteries are magnesium oxide, or the cheater word we use is salt water. There's nothing hazardous in these batteries. You can discharge these batteries to zero state of charge, and it will recharge completely again. You can abuse these batteries endlessly. And I've been abusing these batteries since August. And they fully recharge. There's no outgassing. They're not a fire hazard. They're not an EPA spill hazard. And they're also effectively, in a practical application sense, a one-for-one cost for lead acid. All right?
Great. And we're just about to wrap up. If people need to get hold of you, how can they get hold of you?
Well, they can get a hold of us or get a hold of me through my website, NIDONcomputer.com, or, I don't know if you want to give my phone number out, but the easiest way would be through the website. All you would have to do is type in NIDON, N-I-D-O-N, and the search engine should cough us up pretty quickly, and our contact information is there.
Yep. Okay, and that does it for the day. Thank you so much, Nick Dizon, otherwise known as Battery Nick.
All right, thanks.